Alright, so we'll be starting a loci problem from Pickup and Packer Engineering Drawing, Book 1, page 41, question number 22. I'll sketch the drawing while I also read the question. In the given mechanism on page 41, the crank OA, this is a rough sketch, crank OA revolves anticlockwise about O. The end B of the rod AB, this is rod AB, and the end is constrained to move always along PQ. So for every revolution of OA, AB or just B tends to move only on this line PQ. Plot the locus of R for one revolution of OA if, so we have a point R here and R here. If OA is 30 cm, AB is 105, and AR is 70. And in the question, we're also asked to scale it 1 millimeter to 1 centimeter. So we go right ahead. For OA, using that scale is going to be 3 cm. For AR, it's going to be 7 cm. For RB, or for AB, it's going to be 10.5 cm. And we're good to go. So I'm going to move this out and reveal the drawing paper and begin drawing. So we start with constructing the shaft OA. Since we don't know, we only know that our locus is going to be somewhere here. So we should try and ensure that our drawing paper is fitted well, and we put our drawing on the right side of the paper so that we won't have the drawing off of the paper. So alright, so we've drawn our lines for the circle, and from the question we have OA to be 3 centimeters after scaling it. Alright, and then we divide into 12 parts. Okay, and draw them up together. So we've divided our cycle into 12 parts, and from the question we have that the vertical distance from center O to this B, the horizontal distance, which is this distance, is 60 centimeters. So when we scale it, it's going to be 6 centimeters. So we have from here to here as 6. Remember that we are measuring from 1. That's why we have 7 here as 6. Ideally it's from 0. Yeah, so drawing the vertical line. So we have A, B. B is on this line to be 10.5 centimeters. So let's take this A here to be, this point here to be our A. This is O. So we'll measure 10.5. And then from A as our center, we mark where it touches the line. So we have here. So this is point B. You can name it point B0, point A0, point 00, or A0. Alright, so we have A0. Alright, we can't name this A0. It's going to be always going to be point O. So we have A0, A1, A2, 3, 4. A11. So we draw the line from A0 to B0. From the question, we have an R in between this line, and it's 7 centimeters away from A. That's here. So this is R. So we can begin tracing the other points for the other instances of A as it moves in an anti-clockwise rotation. You get other A instances by copying 10.5 of our original A0, B0 and tracing them on the vertical line. So now we have our first A, which is A1. A2. We might have to extend this line upwards. So, alright, so we have A3. Oh, I'm sorry, very sorry. These are all B's. So this is B0, this is B1, this is B2, this is B3, B4, and so on. So if while drawing you made a mistake, this mistake that I made, you can just clean it off to ensure your work is neat. Clean it off and just put B. That was my bad. So we have A0, A8, B8 already, we've gotten that. So A9, Alright, so the next thing we do is to draw all our lines from A1 to B1 and so forth. Just trying to make sure that it doesn't get you confused, and ensure you by labeling your points, you are ensuring you don't get confused, because local problems deal with a lot of lines, so you have to be careful to label. And A11 to B11, and we're done. So now we simply just trace our original A0 to R0 for the various instances of A. So we have A1 somewhere here. So this is R0, R1 for R2. We have R2 for R3. R3 for R4. R4, R5, So I'm sure you can see the locus already, so we can trace it out. So this is our locus for points R, and now you can take in the original A, B. And A, O. So this is the final work. And so this is the locus of R on line AB.